Today's lesson video is based on chemistry. We are going to look at stoichiometry series lesson videos. This simply means that you are going to have a number of lesson videos whereby we focus mainly on stoichiometric calculation. If you watch all these videos, I'm confident enough that you are going to be good when it comes to stoichiometric calculation. Let us start. Now in this lesson video, we're going to look at the basics, which we are going to deal with these two equations. Now the first one, N, stands for the number of moles. The SI unit is mole. M stands for the mass in grams of the substance. And then this one is the molar mass in grams per mole. Looking at the second equation, this is the number of moles in mole. This one is the number of atoms or particles. And then this one is a constant which is in per mole, that is the SI unit. And then the value is 6.02 times 10 to the power 23. So based on the question and the given data, you will be able to choose the suitable equation between the two on which one to use when it comes to calculation. Let us look at examples. Let's say the question says calculate the number of moles of magnesium when we have 22 grams of this substance. Now, as you can see that the question requires the number of moles N, and we are given the mass of the substance in grams. So the equation we are going to use is this one. Now, if we look at our question and the given data, we are looking for this. We are given this, and then we need this. This is simple. We can actually look at the periodic table. We are going to find the value that we need to substitute here. So looking at the periodic table, we know that the periodic table consists of symbols and numbers. On top you will notice that we have a number, and then at the bottom we also have a number. For example, let us look at hydrogen. Now this number on top, we call it the atomic mass, the atomic number, and then this one we call it the atomic mass. So the atomic mass is the number that we are going to use for the molar mass. The difference between atomic mass and molar mass, the atomic mass doesn't have SI unit, the molar mass is grams per mole. But looking at the values, they are the same. So basically we just substitute the relative atomic mass on this molar mass, which is the capital letter M. So for magnesium, the molar mass is 24. So to answer this question, we have N is equals to the mass in grams is 22 over the molar mass is 24. So this will give us 0.92, or let us round off to 3 decimal, 0.917 mole. Let us look at another example. The question is still the same. Calculate the number of moles of aluminium provided we are given 10 grams of aluminium. So we are going to use the very same equation. And then N is equals to 10 over the atomic mass of aluminium is 27. So 10 divided by 27, we get 0.370 mole. Now this one's there for you, so pause the video, work out these questions and play the video to verify your answer. Now looking at the first one, we are given 43 grams of copper So we're looking for the number of moles. We have 43. The relative atomic mass of copper is 63.5. We get that the number of moles, we have 0.677 mole. Now the second one is 24 grams of sodium. Remember, we start by writing the equation. We have 24 over 23. We get that the number of moles is 1,043 mole. I hope you got these answers correct. Let us look at how to calculate the number of moles of a compound, since we saw that the previous examples we are dealing with elements. Now suppose we have 33 grams of magnesium oxide. We are looking for the number of moles. Now we are still going to use the very same equation, but it will be different when it comes to the molar mass. First, we need to find the sum of molar masses that magnesium oxide is made up of. We know that the atomic mass of magnesium is 24. Actually, this is not the way to write it. We say the molar mass of MgO is equals to the molar mass of magnesium is 24 plus the molar mass of oxygen is 16, which will give us 40. Now 40 is the number that we're going to substitute here. N is equals to 33 over 40, which we get 0.825 mole. So this is how we actually calculate the number of moles when we're dealing with compounds. Let us look at another example. 5 grams of H2o. You may pause the video and try to work out this. Now we are looking for the number of moles. We use this equation again. Now the molar mass of H2O. Now we can see that we have 2 hydrogen atoms, which is H2. So it will be 2 multiplied by 1 molar mass of hydrogen, which is 1, plus we have only 1 atom of oxygen, which is 60. So this will give us 80. So to calculate this, we have 5 over 80, which we get 0.278 mole. I hope you got this one correct. Another example for you. Pause the video, work out this question, and play the video. Now we need to calculate the molar mass of sodium chloride, which we have 23 plus 35.5, which will give us 58.5. So the number of moles, it's M over the molar mass, N is equals to 28 over 58.5. We get that the number of moles is 0.479 mole. Now looking at more complicated compounds. Now suppose we're given 135 grams of this compound. We are looking for the number of moles. The molar mass of this compound, how do we calculate it? We are going to start with copper. The atomic mass of copper is 63.5, plus we have single atom of sulfur, which is 32, plus we have 4 atoms of oxygen, which is 4 multiplied by a single atom has 16, plus when it comes to this part, we should understand how do we actually calculate this part. Now H2O, and then we have 5 here. You should know that this 5 will multiply by the number of atoms on hydrogen and also multiply by the number of atoms of oxygen. Now 5 multiplied by 2, we have 10, and then O2. So when it comes to this part, we are going to say 10 atoms of one single atom of hydrogen plus 2 atoms of oxygen, which is 16. I hope you can understand this part. So from here we can simply punch the whole thing. Oh no, there's a mistake somewhere. This is supposed to be 5, not 2. 5 atoms multiplied by 60. So our answer, we are going to get 249.5 grams per mole. And then from here we can go ahead and calculate the number of moles. The mass, we have 135, then 249.5. We get N is equals to 0.541 mole. Let us look at another example. Calculate the number of moles of magnesium chloride when we're given that we have 10 grams of it. And then the second one, ammonium nitrate, we have 16 grams of this. Pause the video, work out these questions, and play the video to verify your understanding and your answers. Now looking at this one, the molar mass will be 24 plus 2 atoms of chlorine, 35.5. This will give us 95 grams per mole. And then N is equals to M over M. N is equals to, the mass is 10 grams over 95. N is equals to 0.105 mole. I hope you got this one correct. Going to the next one, we are calculating the molar mass of this. We are going to have 14, which is nitrogen, plus 4 atoms of hydrogen multiplied by a single molar mass, which is 1, plus 14 again, plus 3 multiplied by 16. We get that the molar mass is 80, and then N is equals to M over M. N is equals to 16 over 80. N is equals to 0.2 mole. I hope you also got this one correct. What about a compound like this? The challenge is to calculate the molar mass. Now calcium, it has 40 plus. Now how do we deal with this part? It's actually similar to the one I explained previously. This multiplied by this, it will be O2. This and this will also be H2. So that's how we actually treat it. Now we have 2 atoms of oxygen, which is 16, plus 2 atoms of hydrogen, which is 1, is equals to, we are going to get 74 grams per mole. And then we can go ahead and calculate the number of moles, which is m over m. N is equals to 30 over 74, which is equals to 0.405 mole. Now suppose the question says, how many particles does 2 mole of sodium has? Now we are going to use the other equation. Remember, we are given this as mole, which is 2 mole. We are given, okay, we are looking for this, we are given this. So we are going to substitute 2 is equals to n over, remember this is a constant, 6.02 times 10 to the power 23. And then from here we can just multiply by the term causing the fraction. That is mathematics operation, 6.02 times 10 to the power 23. We also multiply this side, then this will get rid of this, and then we have n is equals to 2 multiplied by this, we get 1.204 times 10 to the power 24 atoms. I hope you can see how we apply this equation. Let us look at more examples. This question is a multi-step question. It means we need to calculate something in order to find the actual answer. Now we are given 36 grams of water, and then how many atoms do we have? So we need to calculate the number of moles first. Since we can see that this equation, we cannot use it if we don't have the number of moles, but then we can start using this one to find the number of moles, and then we calculate the number of atoms. Now the molar mass of H2O, we know that the molecular formula of water is H2O. We have 2 atoms of hydrogen and then 1 atom of oxygen, which is 2 multiplied by 1 is 2 plus 16, it's 18 grams per mole. Then from here, number of moles is equals to 36 over 18. We get that the number of moles is 2 mole. And then from here we can actually calculate the number of atoms. So our number of moles is 2 n over 6.02 times 10 to the power 23. Then multiplying both sides, we are going to get now this question, we have 0.5 mole of H2O. Calculate the mass in grams of this sulfuric acid. Now we can use the equation n is equals to m over m, but we need to calculate the molar mass first. Which is equals to 2 atoms of hydrogen plus 32 plus 4, 16. We are going to have 98 grams per mole. And then from here, we are given the number of moles as 0.5 is equals to the mass in grams, and then 98 From here we multiply both sides by the term causing the fraction. In this case it's 98. Then this will get rid of this. M is equals to 49 grams. Our next example, feel free to pause the video and work out this question. We are looking for the mass in grams of magnesium oxide, so we are going to use this equation. Now we know that the molar mass of magnesium oxide is equals to 24 plus 16, which will give us 40 grams per mole. Then we have 0.6 is equals to m 40. We multiply both sides. This will get rid of this. And then the mass in grams is 24 grams. Now this is the end of lesson video 101, which we were dealing with basics. You need to watch lesson 102, whereby we will talk about the molarity and the concentration together with the volume. This is Bahula SJ. Thank you very much.